just a quick note on this checkup. Joe's scores in this situation are bimodal. There are 2 modes, and it's perfectly fine. Section 7 started absolute value functions and graphs. We're going to work with that a little bit more today and talk about vertex form of an absolute value. So 2 definitions for you to consider today. The first is axis of symmetry. Just a big disclaimer before I forget to mention, I call the axis of symmetry the AOS, so I don't have to write out axis of symmetry. The axis of symmetry is an imaginary vertical line, and because it's a line, it has to always start with x equals. Every absolute value you have has to start with an axis of symmetry with an x equals. That's this part right here. If you do not write the x equals, it is technically wrong, so you may want to make a note of that. Axis of symmetry must start with an x equals. It divides the graph into 2 equal parts, kind of like a mirror would if you were looking at it. So if you look at that graph, that blue dotted line is the axis of symmetry. The vertex is the maximum or minimum point. So if you watched the lesson video for 271, you would have heard me say vertex several times. It's the part where the V actually makes a V, and it is an ordered pair, an X and a Y. So if you look at the graph that we have, the vertex there is 2, 1, because X is 2 and Y is 1. You'll also notice that the X value of the vertex, oh, that was a poor color choice. Sorry about that. Let me just do this. The X value of the vertex always matches the x equals for the absolute value, or the axis of symmetry. It will always match. General form of the absolute value function is written there for your use. I'm pretty sure there's spots on your notes for it. Couple of things for you to consider. A is the compression or stretch factor. There's a typo there. HK is the vertex, and x equals h is the axis of symmetry. So I'll show you what I mean by that in 1 second, but all of that information is there for you to write down. So we've been, for the last couple of days, looking at how we can transform functions. And so I've given you a function up there, and lots of transformations have occurred. And what's written in red has been what you've been used to. That negative out front is a reflection over the x-axis, which flips my graph down. The 3 is a stretch, and it ends up being my slope. I end up going up 3 over 1. The plus 5 inside moves me left 5, and the plus 2 outside moves me up 2. Well, today we're going to talk about the blue information. If I've moved left 5, I'm now at negative 5. And if I've moved up 2, I'm now at positive 2. And so today we're going to talk about the vertex. The vertex of this graph would be at negative 5, 2. And the axis of symmetry would be x equals negative 5. Remember, those match. Okay, so that's what we're going to look at today. That's just slightly new for you. So take a look at example 1. They want the vertex and axis of symmetry of the absolute value graph, and they want to know how the parent function is transformed. So you can kind of take care of both of those at the same time. So the first thing I'm going to look at are transformations. The 2 out front stretches by 2, which ends up being my slope. The minus 1 inside moves me right 1, and the plus 4 outside moves me up 4. Well, think about what happens on the graph if you do that. If you move right 1 and up 4, that ends up being your starting point. That point right there is called your vertex. And it occurs at 1, 4. I moved right 1 and up 4. I also know that my axis of symmetry, which must start with an x equals, will be x equals 1. And when you draw the axis of symmetry, it is a dotted line that goes right down the vertex. And that'll help you when we're graphing a little bit later on, especially with x squared graphs. We can still count off the slope like we used to. Remember that this has been stretched by 2. So from my vertex, I'll go up 2 and over 1 to one side, go back and do it to the other side. And you're all done. Connect them with arrows on both ends. Should be good to go. Take a look at the second one. The 2/3 out front is compressed by 2/3. It's a compression because 2/3 is between 0 and 1. The plus 3 moves me left 3, and the plus 1 moves me up 1. So I'm going to put letters to this one for you. If I move left 3, that means my h value is negative 3. And if I move up 1, that means my k value is 1. So my vertex is now at negative 3, 1. Negative 3, 1 is right there. I have moved left 3 and up 1. I know that my axis of symmetry, which must start with an x equals, will match h. So negative 3. That means I've got this vertical line that goes right down the vertex. My slope on this equation is 2/3. It's compressed by 2/3. So from the vertex, go up 2 and to the right 3, then go back to the vertex, go up 2 and to the left 3. You should end up finding a flatter graph than last time because last time was stretched and this time was compressed. Compressions make them flatter. Letter C. First thing I notice is a negative out front. That's a reflection in the x-axis. I see a 3, which is a stretch by 3. I do want to take a 5-second timeout to remind you of two things. First, stretches and compressions can never be negative. So if you see a negative in front of a stretch or a compression, that's actually, in addition to the stretch or compression, a reflection. Also, when you list a stretch or compression, you must give its factor. In this case, the factor of this stretch is 3. The +4 inside moves us left 4, which today now tells us that h is negative 4. And the -2 on the outside moves us 2 down, which now today tells us k is negative 2. That gives me an ordered pair of my vertex. hk is negative 4, negative 2. Negative 4, negative 2 is in the third quadrant. I know that my axis of symmetry must match my h value, so it's x equals negative 4. Pause for a second and make sure you specifically need the x equals. That's this one right here. You need that. It is not a choice. Draw in your your axis of symmetry before you keep going. The vertical line drops right down the vertex. From the vertex, count off your stretch or compression. Now remember, this has also been reflected. So I'm actually going to go down 3 over 1 and down 3 over 1 the other way. It has been both stretched and reflected. So you end up having an absolute value function in the third quadrant that is relatively skinny because it's stretched and opening down. Letter D. Letter D is tricky because of the order of which they wrote it. But you can rewrite it. Just take that 4 and push it to the end of the equation. I do want to note that I'm not moving it to another side of an equation. I'm just rewriting one side. So I'm not going to undo any operations. I'm just going to let the negative 1/4 times the absolute value of x minus 1 first, and then the +4 on the end. I did not change the sign of the 4 because I didn't move it to the other side of the equation. I just moved it to the back of the same side. So, a couple moves that have occurred here. I see a reflection on the x-axis. I see a compression by 1/4. I see a right 1 inside and a +4, which is an up 4 outside. I know that that right 1 means h is 1, and I know that that +4 means k is 4. So my vertex is 1/4. 1/4 is not right there because I can't count. Can I? Oh yeah, I can. And I know that my axis of symmetry, that starts with an x equals, has to match the h, which is 1. So my axis of symmetry will drop right down the vertex. And from there, I can count off my slope, which is a negative 1/4. The slope is comprised of both your reflection and your stretch and compression. So from the vertex, I'm going to go down 1 over 4 on this side, then go down 1 and over 4 on the other side, before you can draw in the absolute value function. This should both open down and be really flat because a compression of 1/4 is really flat compared to most. Pause the video and you try it. So the only other thing we need to do today is get an equation from a graph. So the first thing I would do if I were you is get yourself a vertex. Vertex is the point at which it forms the V. So this vertex, this problem, is occurring at 0, -2. That means my h value is 0. Oh, wrong one. Ooh. And my k value is -2. Now, okay, when it comes to general form, vertex form, I'm going to write it down here so you can see it. It's what you wrote on the front of your notes. I need an A, an H, and a K. I've got H and K. The only other thing I need is A. And A is the value that you have to rise and run to get to the next point. So I see a nice point over here. I have to rise 1, 2, 3, and run 1, 2. That means that my A value is a 3/2. This has been stretched. 3/2 is larger than 1. So if I substitute A, H, and K into this general form that I have, I get y equals 3/2 times the absolute value of x minus 0 minus 2. Now, to be honest with you, that minus 0 bothers me a little bit, so I'm going to just rewrite this as a final answer. I get y equals 3/2 times the absolute value of x minus 2. This is the answer you would be looking for, because the minus 0 is redundant. Take a look at letter B. The vertex here on letter B is 2, 1, which makes my h value 2 and my k value 1. I need to find A, so I'm going to use this point right here. My A value is up 2 over 1, which is the same as 2, and it is positive because it opens up. So if I substitute A, H, and K into this form, I get y equals 2 times x minus 2 plus 1. Letter C, the vertex on letter C here is a 1, 2. And my A value here is going to end up being negative because it's opening down. This one's opening down. So I see a point that crosses nicely right there. In order to get there, I need to go down 1 and over 2. It's a -1/2. So my equation is y equals -1/2 times the absolute value of x minus 1 plus 2. Take a second and point out all of these are minuses. Okay, so the only time it becomes positive inside is if your h value is negative, like in letter D. In letter D here, the vertex is at -2, 3, which makes my h value a -2 and my k value a 3. Now count off your slope, your a value. You see a nice one right there. I have to go down 1, 2, 3, 4, 5, and over 3. That makes my a value a -5/3. I went down 5 and over 3. So if I substitute, I get y equals -5/3 times x. And instead of minus h, my h value is negative. I'm going to make this a plus 2 because it's x minus h, but h is negative. And then finish with your plus k, which is plus 3. Pause the video to do the you try it.